Hi there, welcome to this video on graphing sine and cosine functions while incorporating phase shifts, which is going to be a horizontal translation to what we already know about sinusoidal functions with amplitude and midline. Okay, so really learning how to graph trig functions. This is video 2, I guess, in a 3-part series. We're going to learn about phase shifts incorporated into graphing sinusoidal functions. Okay, so we're learning to graph trig functions. You'll be successful if you can identify amplitude, period, midline, and phase shift is the new word for this video. You'll be successful if you can graph transformations of sine and cosine functions when there is a phase shift, and you know your quadrantal values for sine and cosine. So just a reminder about sinusoidal functions and their general form. Remember, f of theta equals a times sine of b of theta plus c plus d is the general form. And again, we can swap sine for cosine. It's exactly the same idea, but these are our parameters: the a, the b, the c, and the d. And just a quick refresher about what these do. The first one that we have is amplitude. Your a value will change your amplitude of a sinusoidal function, and if it's negative, it will cause a reflection. Okay, so just something to pay attention to there. Your a value affects amplitude. Your b value, we'll cover this in the next video, but your b value will affect period. Your period is going to be 2 pi divided by the absolute value of b. And then your c value, this is what we're talking about today. This is your horizontal translation, also called a phase shift. And whatever we see here, if it's plus a value, you're actually going to the left. So remember that kind of with your parameters that are involving your independent variable, they're always different, right? Your b value, you take the reciprocal of, and your c value, it's always the opposite. It's always negative c, okay? That's phase shift. And then the last one we talked about in a previous lesson is the d value. This is your midline that moves your graph up and down, okay? So again, here's just kind of like a summary of that. Period is 2 pi divided by absolute value of b. Phase shift is negative c. Amplitude is the absolute value of a. And your midline will always be d. Okay, so we're going to go ahead and look at some functions. Here's some notes for you. If you want to pause the video, you can read these. This is a method for graphing sine and cosine, but I'll kind of cover this in our videos of our examples. Okay, so let's go ahead. Let's jump into the very first example. And this example is g of x equals negative cosine of x plus 3 pi over 4 minus 2. So the first thing we're going to do, we're going to identify these values that they're asking us from this symbolic form. The first one is period. Period, remember, is always 2 pi divided by the absolute value of b, which in this case, our b value is 1. So nothing affecting our period yet. Our amplitude, I have an a value that is negative 1. Amplitude is going to be the absolute value of that. So our amplitude is actually 1, but that negative will come into play. And then I have midline. Middle of the graph is your midline. That comes from the d value, and the d value here is negative 2. So y equals negative 2, which means that we are shifting our graph down 2 units. So negative 2 will be the center of the graph. And then lastly, here's what we're talking about today is the phase shift. The phase shift moves us left and right. You'll notice that your c value here is 3 pi fourths, 3 pi over 4, I guess, or negative. You can think about that. But our phase shift is negative 3 pi fourths. I'm getting shifted to the left 3 pi over 4, okay? So we're going to go ahead and graph this cosine function. So again, kind of what I do, this is my step process, is I always graph the midline first. I like to know kind of centered down where I am. And then number 2 is where are we starting? Where are we starting? And so this kind of comes from a couple of things. One is what function do you have? What's our function? In this case, I have a cosine theta function. And what that means is it means I'm going to start at an extrema. I'm going to start at a maximum or a minimum. Okay, so maximum or minimum, not the midline. That would be sine function. Now what you should note here is that your a value is negative. Notice how a is negative? So that's going to cause me to start at my minimum for my cosine function, okay? So I'm doing that, but what also I have to worry about too is I also have to take into account my phase shift, So I have a c value here of 3 pi fourths, so I have to go back 3 pi over 4, 3 pi over 4. Now, looking at our graph, each unit is half a pi. So here's pi, 2 pi, so pi over 2, negative pi, negative 3 pi over 2. So pi fourths would be kind of in between this. So I don't know if you need to do this. So half of a unit would be a pi fourths, and we want 3 of them. So if I'm going backwards, 1, 2, 3, it's going to be right here, okay? So I bring that up because this is where we're going to start. This is our phase shift, okay? And so my starting point will be here, and then this is the midline, and our amplitude's 1. So it looks like negative 1 is going to be our max, and our minimum will be negative 3. Now, where am I starting? I already know, I already kind of shifted this, and so I wouldn't draw this, but if you really need to, it's kind of like this is like your new pseudo origin, this location right here. This is like your new pseudo 0, 0, and I'm going to start at my minimum. So I'm going to go down 1. That is going to be right here. So this is my very, very first point. This is the start. This is so important when you're graphing these functions is where do you start? You have to take into account the midline shift and your phase shift, right? I went down 2 and I went back 3 pi fourths, and this is where I'm starting. I'm starting my minimum because it's a cosine function that's negative. If it was cosine that was a positive, I would be up at my maximum, which is a positive, or it would be negative 1. I'd be up here. Okay, if it was a sine function, I'd be at my midline. Okay, now our period is 2 pi, so we want to go ahead and also graph the end, right? So I like to do start and end, I guess step 3 here, start and end, and I gotta go forward 2 pi, so let's see if we can go ahead and kind of figure this out. From pi to here, that would be 1 pi, duh. To another pi, that would be 2 pi. Okay, so notice how I'm like, you know, a half a unit in front of pi, right? So this would be 2 pi. So from here to here would be 2 pi. So that kind of means that I'm going to end right here. Okay, so I kind of use the general markers to help. Sometimes your units are nice and you can figure it out. Sometimes not. Okay, so now that we have the start and the end kind of planned out, we can again just go ahead and split this. So right in the middle, right, is going to be, you know, right here. Okay, halfway between. And since I have minimums for cosine function, it's going to be a maximum. So here is my maximum value. And then between those two are going to be midline points, right? It has to go, your key points have to go min, midline, max, midline, min, midline, max, midline, in one of those orders, right? So minimum, and then I'm going to have a midline, okay? Then a maximum, and then a midline, okay? And so here's one cycle of my curve, and there you go. Okay, so there is your cosine function. And then again, we can kind of just repeat this process. So midline, maximum, midline, minimum, midline. Okay, and so again, whoop, here you go. And there is another cycle of your curve. Okay, and we can extend it this way as well, to the left. So again, midline, maximum, midline, minimum, midline, maximum, and so this is what our curve will look like. Alrighty. Okay, So again, I just kind of want to show you too, again, this was a cosine function. So I have here on Desmos kind of a graph. So I'll turn on the cosine function. Here's your cosine function at 1. So some important things. This one had a d value that was a negative, what was it? Negative 2? Negative 2. Okay, so notice I'm shifted down 2 units. Okay, so there's the shift down. And then we were back 3 pi fourths. So my curve, and again, the point to watch would be your maximum point here. Okay, so I'm back 3 pi fourths, which looks roughly about there. And I can change this, negative 3 pi divided by 4, right? So there we are. Okay, and so I'm there, and then our a value was negative, and so we had that reflection, right? So that's why we started at a minimum, then we go midline, then we go maximum. Okay, all right, cool, sweet. Let's look at another example here before I have you do a practice one. I want you guys to catch another example one. Okay, example 2. Let's look at this example where we have an a value that is negative 2, where we have a b value. This is your first look at a b value and what happens with a b value. So our b value here is 1/2, and our c value we can see is a, I like to call it a pi over 2. I want to switch it. So it's positive pi over 2. We're going to go right pi over 2. And then our d value, which we don't have, is 0. So what are the effects that these parameters have on our graph? Well, our a value affects amplitude. So amplitude is going to be the absolute value of that a, which is 2. Your period is 2 pi divided by the absolute value of b, which is 1/2. So this actually stretches out our period, right? So normally it's 2 pi, but I'm dividing by 1/2, so you multiply by the reciprocal. So 2 times 2 pi, which is 4 pi. I'll squeeze that in there. 4 pi, okay, so we got a longer graph. And then we have a phase shift from C, so I'm going to go right pi over 2. And then our midline is 0, y equals 0, okay? So those are what the parameters do and kind of their effects on the graph. So I have my graph here, and I graph my midline, but the key thing again is, where do I start? So where am I going to start? Now, please note this is a sine theta function, which means you're going to start at the midline. Now, you do have a phase shift. It's pi halves, so I'm shifting my graph to the right pi over 2. So again, if you need this kind of dashed line here to say, hey, here's like your new pseudo origin, you can do that. But this is going to be my starting location. And then I need to know, where do I end? Where do we end? And this is where period is going to come into play. The period is 4 pi. So notice I'm already pi halves this way, so 4 pi would be here. Means pi halves is going to be right over here. I'm off the graph a little bit. So for our sakes and purposes, I'll just do that, because then we want to go ahead and start to graph our key points, right? So we want next the key points. So in between your start and your end is going to be another midline for sine, right? And then in between those is going to be an extrema. Now, since this is a negative 2 a value, I'm getting reflection. So sine normally goes up to a maximum, midline, and then a minimum. But because it's negative, I go down. I start to go down. And our a value was negative 2, so that means the amplitude is 2. Okay, minimum at negative 2, and then I'm going to go up here to positive 2. Positive 2, okay? So here's one cycle. Concave up, concave down. Okay, we're kind of off our graph there. And then we can extend this, right? So just note, look at your key points. Hey, each 2 units I'm going to have a key point, right? So if I go backwards, 1, 2, I'm up at a maximum, 1, 2, midline, 1, 2, minimum, 1, 2, is another midline. And then 1, 2, we're back at, over here should be a max. Okay, so our graph, okay, concave down, and then through here, concave, whoop, I can do better than that, concave up, concave down. Okay, so there you go. There are the two examples for how we graph with phase shifts, and this one had a period change. Okay, so here's what I want you to do. I would like you to pause. Actually, I guess before that, I'll go ahead and show you this one. Let me just reset this A value to 1. We did have a B value that was, well, I'll keep it at 1 for now. 0 and 0. Okay, so this was a sine function. Let me turn on sine. Okay, so here's our sine graph. Your midline, again, was 0. Your h, we ended up going to the right, pi over 2. So I'm at pi over 2 right there, if I can get it. Okay, and then our a value was negative 2. So I ended up reflecting, amplitude went to 2. Okay, and so from midline, we go down. And then the other thing was our period. Our period was 1/2. So let me go to 0.5 here. So from 1, watch how this looks from 1/2. It's elongating out. So our b value is 0.5. Okay. Oh, and I think this function's mixed up. I gotta add this in to get it right. Okay, so notice phase shift, and then we went ahead and we stretched it out, right? So to 0.5. Okay, so please pause me. I want you to try this example here. Okay, go ahead, pause it, and then try this example. I'll show you the result here in a second. Okay, before we go ahead and proceed, I just want to make sure that you have these values right. A is 3, B is 1, C equals pi over 2. You're going right, pi over 2, and then D is 0. So your period, unchanged. It's 2 pi. Amplitude is 3. Midline's at 0, and phase shift is pi half. Okay, keep going. Pause, and then I'll show you the results. Hey there, just jumping in. This is what one cycle should look like. You should start at pi over 2 because of our phase shift, and then I'm going to end 2 pi later, which is just pi halves after 2 pi. In between will be midline, and then in between your midlines will be your extrema. So we'll start with the maximum because it's a positive a value. I go up 3, and then your minimum will be down 3. Okay, all right, and I'll show you the finished product here when you extend left and right. Okay, here you go. Here is the rest of the graph extended from left to right. All right, next example, here you go. Please go ahead, pause the video. I want you to try this example, but make sure you watch out. This one does have a b value. So check back in. I'll show you the parameters and their effects on our kind of key features of our graph. So pause, try it, and then check back in. Okay, checking in with you. A is 2, that's your amplitude. It's positive, so it's going to be positive 2. Your b value is 4, so that means your period is 2 pi divided by the absolute value of that 4. So you get a pi halves. Pi halves is your period. C is negative pi fourths, so you're shifting left pi fourths. And then D is equal to negative 1, so we're shifting down 1 unit. Okay, so check back in. I'll show you the first cycle here. Okay, checking in here, this is what your first cycle should look like. Your midline is negative 1, so you're down here, and then we shift back pi fourths. Now notice the units on your graph are different, so they're changed to pi fourths, right? And so halfway in between that, that'd be pi eighths, right? So pi fourths, I'm going to start here, and I'm starting at a maximum of 1 because my amplitude's 2. So I'm shifted down 1, that means I go up 2. So I'm starting at cosine, means extrema starting point, so we're at the maximum because it's positive. And then our period, where we end, is pi halves. Period's pi halves. So I have to go over pi halves. This can be a little bit challenging. A couple of ways you can do this. You can think about, okay, this is pi fourths. This is 1 pi-fourths. So another pi-fourths would be pi over 2. Or you can just kind of count the units, right, to pi-halves. Here's pi-halves, so I have to go over 1, 2, 3, 4. So 4 units makes pi-halves. Anyway, here's where you start, here's where you end. In between is going to be your minimum, and in between those will be your midline. So does your first cycle look like this? Awesome job. Okay, pause me now. I want you to extend this left and right and complete this graph. Okay, here you go, and here is what this graph would look like. All right, I'm going to go ahead and just kind of recap. In this video, we talked about phase shift, and we looked at how we have a period change that would change our graph. Hopefully in this video you know how to graph a sine and cosine function, and how to adjust for a phase shift and a period change. Check back for part 2 on this lesson, and I'll see you in the next video.